All right. Hopefully you guys are having a good day. Things are going well for you. We're going to do a little bit more absolute value work today. We are on lesson 3 of unit 4. All right, and we're going to work with solving mixed systems of equations graphically. So this is really going to encompass 2 or 3 days worth of work, and we're going to look at the same idea, but we're going to take the first day today to talk about it graphically, and then we're going to talk about how do you do it algebraically over the next couple of days. So here's what I would like you to do. All right, we have an opener here. You're giving 2 absolute value functions. I would like you to graph those functions, determine what points they intersect if they do intersect, and then verify your solutions algebraically. All right, so once again, do all that work. You can do your verification out here in this blank space out here to the right. All right, so go ahead and pause the video, complete the opener, and then turn it back on, and we'll see how you did. All right, so I'm going to show you my work here real quick and see if it matches your work. All right, so graphing f of x here, we see that the vertex is 3, -2. It has a positive 2 for an a value, so up 2 to the right one, up 2 to the right one, up 2 to the left one, up 2 to the left one, so you can see my first graph. G of x has a vertex of 3, 2, so it starts here, but its a value is -2, and so you can see my graph. And we do get 2 points of intersection, 2, 0, and 4, 0. Now, what do we mean by verify algebraically? All right, just in case you don't remember this, what this means is that when I plug in 2, all right, into f of x, I should get 0. All right, and that's what happens here. When I plug 2 into g of x, I should get 0 again. And that happens. So what this is saying is that 2, 0 is in fact on both equations, or on both graphs, and we verified that. And then we would do the same thing with 4, 0. All right, I would plug 4 in for x here. You can see my work, and I do in fact get 0. When I plug 4 into g of x, and you can see my work once again, we get 0 again. So what we're doing when we verify algebraically is we're just giving some proof that both points, all right, are on, each point is on both graphs. All right, so this says 4, 0 is on f of x, this says 4, 0 is on g of x, and then if it's shared by both graphs, that is a point of intersection. All right, so there you go. So now let's look at the next line here. So if a point is a solution to a system of equation, all right, then it makes both equations true. All right, and they should have the same value. All right, so if, and I'll just write this kind of above here, if I plug a in here and I get b, right, and if I plug a into g, I should get that same value. All right, so it makes it both true and we get the same value. So what this is saying is that the point AB is a solution to both equations, which then means it is an intersection of those 2 graphs. All right, so let's go through a couple of problems here together. All right, so we have our whole class practice here. I'm going to adjust my camera just a bit here. There we go. All right, so what we want to do is just graph our equations. All right, find those points of intersection if they exist. All right, and then we are finished. So if we look at f of x here, one of the first things you always want to do is look at the type of function you have, so you can have a picture in your head to graph it. So we know this is an absolute value graph based on the absolute value bars. We know the vertex is -2, -1. So right here, and we have that positive a value. So we're going to go up 1 to the right 2, up 1 to the right 2, and I'm going to do this maybe more than you would normally if you are just graphing, because we're looking for a point of intersection. We don't really know where that point is going to be, so I'm going to just extend that maybe a little farther than you normally would, all right, each direction here for our absolute value graph. There we go. So draw that dude in, all right there. Draw this branch in right there. All right, so hopefully your hand's a little steadier than mine. Okay, so now we're going to move to g of x here. All right, so we have f of x here. All right, so let's draw g of x. -2x plus 5, it's a linear equation. It's in slope-intercept form. We start at +5. We have a slope of -2/1, so down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, and there it is. All right, and we can see that we get just the one point of intersection, and that point of intersection, which is a solution, would be 2, 1. Now, if you wanted to check your work, if I plug 2 into f of x, I should get 1. If I plug 2, and you can see that here, negative 2 times 2 is negative 4 plus 5, I get 1 there as well. So the point of verifying is to also give you a way of checking and verifying your answer. All right, so let's look at number 2 real quick here. All right, so once again, we have an absolute value equation. The vertex is negative 1, negative 6. All right, so negative 1, negative 6 right here. All right, we have that negative a value of 3. So I'm going to go down 3, 1, 2, 3 to the right 1, down 3 to the left 1. And you can see that we run out of room. So that's all we can do. So we'll just do that. We'll do that. All right. Okay, now we have y equals negative 6, which is a horizontal line through negative 6. So that would be this line here. All right. And now what we see is that vertex of our absolute value is the only time these two lines intersect. All right, and once again, that means our intersection, all right, is negative 1, negative 6, and that is our solution. All right, that is all for now, my friends. So hopefully you feel really good about this. Most of this is review. It's just graphing absolute values, graphing lines. We'll do a little bit more work when we come to class tomorrow. All right, but have a wonderful afternoon. Do your video check-in, and we will see you next time.